Let's try this question by applying difference of squares. What times what becomes the first term? 5x to the 4 multiplied by 5x to the 4 indeed is 25x to the 8. Plus minus, what times what becomes the second term? We can write y over 3 times y over 3 becomes y squared over 9, because we multiply across. So this is one way of factoring it. For fun, let's try factoring in a slightly different way. We see that we're dividing by 9, so can we pull out the GCF of 1/9 out just to get rid of the denominator? We prefer integers. So 1/9 times what is 1/9 times what becomes 25? It's going to be a large number. So 25 times 9, 25 times 4 is 100, 25 times 8 is 200, so 225 divided by 9 is 25. It takes 9 quarters to make $2.25. So we're just trying to reconstruct this original question. 1/9 times negative y squared becomes the second term. And now we can apply difference of squares again. What times what becomes the first term? What's the square root of 225? 15. 15x to the 4 times 15x to the 4 indeed generates the first term. Plus minus, what's the square root of y squared? It's going to be y and y. So this is also equivalent. Now, for the sake of algebra practice, let's try to see the connection between our first and second answers. When we look at the fraction here, you can also write this, I'm going to just keep my square brackets here, as 1/3 times 15x to the 4 plus y. I'm factoring out a 1/3 from this left term here, because indeed when you multiply this and then this, you can see that it's equivalent. Similarly, I'm factoring out 1/3 for this right term, for this right factor, that is. So 1/3 times 15x to the 4 minus y. And clearly, 1/3 times 1/3, you can multiply these because multiplication is commutative, you can move them around left and right, is 1/9. And so you can see that these expressions are equivalent. And now it's your turn. Try factoring 16x to the 6th minus 4 over 25 and 4x to the 100 minus x squared y 10 all over 121.